Welcome to Manish Kumar channel. So today we are going to discuss about regions in the complex plane. So first of all we define what is a neighborhood in the complex plane. So definition, neighborhood is the set modulus of z minus z naught is less than epsilon. A neighborhood of a point z naught consists all the point z laying inside the circle centered at z naught with radius epsilon, right? So we call it as the neighborhood of z naught. Okay, what is a deleted neighborhood of? So deleted neighborhood means deleted neighborhood of z naught. So z naught is removed, right? So it means center is removed basically, right? So this is 0 strictly greater than z minus z naught is less than epsilon, right? So now graphical interpretation. So this is a center z naught and radius is epsilon. This is the radius epsilon, right? And any point z, so z minus z naught, the modulus value. This is the modulus value z minus z naught, right? And which is less than epsilon. So any point around this z naught, right, will form a disk, right? So this disk has radius epsilon. So any point inside it will be your neighborhood of z naught, right? Because the neighborhood means the neighboring points, right? So epsilon will be very small basically here. Epsilon is less than 1 basically and greater than 0, right? So we call it as the neighborhood of a point, right? As epsilon as small, the neighborhood contains around z0 means a lot of points are there, right? And deleted neighborhood means the point z0 is removed. Z0 is no longer there, right? All the points in the neighborhood. So now if you see in the real line, the neighborhood of a point means at any point x0 is going to be an interval, right? Similarly, if you see neighborhood on the y-axis will be again an interval, right? Some y naught. So you see z naught is equal to x naught plus I y naught, right? So you are going to reach somewhere and then you see this will form a shape like this and this will form a shape like this, right? Assume this has epsilon 1 and this has radius epsilon 2. So this neighborhood satisfy the condition of minimum of epsilon 1 and epsilon 2, which is going to be epsilon. So therefore in 2D, in complex plane, the neighborhood becomes a circle, a disk type, right? In real line, neighborhood is an interval, right? But in complex plane, neighborhood becomes a disk. Okay, so these all are the deleted neighborhood and without deleted neighborhood only of a point z naught in complex plane. Okay, so types of points. So this point in the neighborhood, what are their characteristic, these points? So we are going to talk about these points. Okay, so types of points. So interior points, when we call a point is to be an interior point, a point z is an interior point if neighborhood of z is fully contained in the set, right? It means that suppose if you have a set as, okay, and this point is an interior point, if you draw any neighborhood looks like a disk, right, of radius epsilon, right? So at this point, let's say this point is Z1. So neighborhood of NBD of Z1, right? Neighborhood of Z1, we are writing in short NBD of Z1, right? This is as N, and then point, let's say center is Z1, and then radius is epsilon. We can write some way like this also. Okay. So this neighborhood completely belongs to S. So this S contained that neighborhood N Z1 epsilon, right? And Z1 is already belongs to this neighborhood. Z1 is already inside the neighborhood, and neighborhood completely lie inside of it. So if you see this point is an interior point, draw a neighborhood. That neighborhood completely nest. This neighborhood, draw a point. So any point inside this S is an interior point, right? So this neighborhood completely contained in the set, right? So this property means it is enough to show only one neighborhood works for it, right? Okay. So all such collection of those point will be an interior points, right? What is a boundary point? A point whose neighborhoods contains points both inside and outside of the set. Means if you take any point on this and draw a neighborhood, any tiny neighborhood, if you try to prepare, what happened is some points are outside of this set, right? Some points are outside of this set, and some points are inside the set, right? So which is called a boundary point. Okay. And a point is said to be an exterior point if you can draw any neighborhood around this point and it's completely outside of S. So exterior means outside S, interior means inside S, having a neighborhood which entirely lie on S. Boundary on S means the neighborhood contains some point of S, some point outside of S. Right? This is the meaning of these 3 points. Okay. So you can see it is an example. So this point, let's say Z1, is because completely lie in this set. This is my set S. So neighborhood completely belongs to S. So this is an interior point, right? And if you draw a neighborhood around any point on the circumference of the circle, then every point contains some point outside of the set, some point inside of the set. Then this is a boundary point. And exterior point means any neighborhood which does not belongs to the set itself, right? Now, when we say a set is said to be open or closed, so a set is open if it contains none of its boundary points, right? Or all interior points. So set is said to be open if it consists all points are interior points, or it does not contains boundary point. None of its points are the boundary point. Okay. A set is said to be closed if it contains all its boundary point. Okay. And a set can be neither open nor closed, right? So look at this punctured disk. We have removed the origin, right? So this is a punctured disk. We have a disk which is punctured. Okay. Z0 is 0 is removed. Okay. So this punctured disk is neither open because close boundary point on the circumference is there, but the boundary point is not there around origin, right? So this is neither open and nor close. Why it is not close? Because boundary point is included. A set is said to be open if it contains none of its boundary points. So it is consisting of boundary points on the circumference z equal to 1, radius z equal to 1, right? So this is neither open nor closed set. If I want to make it open, so 0 less than mod z less than 1. So this is open. If I want to make it close, so 0 less than or equal to and less than or equal to 1. So this is closed set, right? Okay. So when we say connectivity, a set is connected if any two points can be joined by a polygon line within the set, right? So if you see this set is connected or not, modulus of z, so this set is open, right? Open because none of the boundary points are there and every points are interior point. You can draw a neighborhood which completely lie on it, draw a neighborhood which completely lie on it, right? So these boundary points are removed actually, right? Then in that case, this set is open. Connected means if I want to take the point here and then point here, I want to join them. If I join by the line, right, then this is completely outside of the domain, which we do not want, right? So I can use another way to join them like this and like this. So you can join by any polygon line, right, which completely lie inside of this set. Yes. If I say this set is yes, this set is yes, then the line can be joined by polygon and that line must completely lie inside of S. Then we can say that the set is connected, right? A set is said to be simply connected if it has no holes. So this set has hole, right? So this is not simply connected, right? So simply connected, very simple example, modulus G less than 1. So all the points inside the center 0, 0, right? And radius 1 and boundary point is not included. So this is open as well as connected, right? Because there is no hole. Okay. So simply connected. This is a simply connected set. Okay. Okay. So now let us talk about a bounded set. A set is said to be bounded if every point of that set yes lies inside some circle modulus of z equal to r, where r is finite radius circle, right? Otherwise it is unbounded. So let us see this example. Real part of z means x is less than or equal to 0. So if we have the plane, right? So real part of z which is equal to x is less than or equal to 0. So x less than or equal to 0 means this side. So this is half plane, right? So now if I am going to like construct a circle mod z equal to r, some radius r, right? So I cannot cover this entire your half plane because this goes to minus infinity, right? And as long as r is only finite, r has to be finite value, right? So you cannot cover with infinite value. This half plane cannot lie inside this circle. Therefore, this is unbounded. Okay. But if I say modulus of z is less than 1, then this is, your circle. You can always find a bigger circle. This is your yes. You can always find a bigger circle of radius r, right? Which completely contained your set yes. Okay. So this means this is a bounded set. Okay. So a point z naught is an accumulation point. Sometimes we call it as a limit point, right, of a set yes if each deleted neighborhood of z naught. There are several way to define this accumulation point. So one of the way is deleted using deleted neighborhood, right? We can also define using neighborhood as well without taking the deleted neighborhood. But let us first define with the deleted neighborhood. So each deleted neighborhood of Z naught contains at least one point of S. But of course, not one point. There are infinitely many point of S, right? So each deleted neighborhood, right, contains at least one point of S. Okay. And a set is said to be closed if it contains all its accumulation points, right? So for example, you see the origin is the only accumulation point of the set Zn, I to the power n by n, where n equal to 1, 2, and so on. So now let us see how the structure will be. N equal to 1, I'm going to get Z1, which is nothing but I by 1, which is equal to I. N equal to 2, I'm going to get Z2. Z2 is I square by 2. I square is minus 1, so minus half. And similarly, you can reach for each n. So if you see I equal to 1, this is imaginary axis. So Z1. N equal to 2, uh, minus half. So Z2 will be here, right? Similarly, Z3, Z4, and so on. So on all the axes, it is going to be like, decreasing type, right? But what had happened is, I want to prove what is the limit point of this set. So let us say Z1. Is Z1 is a limit point? So Z1 is a limit point if each deleted neighborhood of Z1 contains at least one point of S. So I can prepare a neighborhood around Z1, right? Deleted neighborhood means none of the other point of S is coming into the picture of this neighborhood. So this is not a limit point, right? Similarly, Z2, I can prepare a tiny neighborhood like this. So none of the points are coming in the neighborhood, right? Because yes, any point of yes should also be there except this Z2, Z1, and so on. Because deleted neighborhood we are talking about, so we will not consider this point in the neighborhood actually. Z1 and Z2 and so on. Similarly, I can also construct a tiny neighborhood that does not contain because each deleted neighborhood. So if I'm able to show that any one of the neighborhood is not consisting a point of yes in the deleted neighborhood, then it is not going to be a limit point, right? And but whenever you reach towards n tends to infinity, right? N tends to infinity, so z infinity will looks like 0, right? So whenever you reach towards 0, if you try to prepare any neighborhood, any tiny neighborhood, right, of the deleted neighborhood of 0, then that set, that neighborhood contains at least one point of S, right? Therefore, 0 is the limit point of this set. Okay. New problem, if I say very simplest one, let's say Sn is 1 by n only. So you can understand in a very easily in the real line. So let's say this is your 0 and this is your 1. So first point is here, right? And second point will be here, half, right? Second point will be at half. Third point will be at one third, somewhere, one fourth, and so on. And then you see it is decreasing towards, this set is reaching towards 0, right? But in 0, 0 neighborhood, whenever you prepare, you will always find a point of yes, which is enclosed by this deleted neighborhood, right? But for this, I can prepare because every neighborhood should contains a point of yes in the deleted neighborhood. So I'm going to prepare depending upon my requirement that neighborhood size. What is the neighborhood radius? I'll be taking a smaller radius here so that no point will come of s in the deleted neighborhood. Similarly, a smaller radius so that no point will come in this neighborhood and so on. But this is not possible for me to construct any tiny neighborhood for small radius. It definitely encloses a point of s, right? So in the deleted neighborhood, at least one point of s must be appear. So that is going to be the limit point, right? Okay. So now the limit point of this set is singleton 0, right? For this set or for this set as well. Okay. So let us verify one more strong result of real analysis. Bolzano-Weierstrass theorem. Every infinite bounded set yes has at least one accumulation point. So if you see this set, let's say this set is infinite, infinite set, right? Also bounded between 0 and 1, right? The bounds are 0 and 1, right? So this set is bounded. Infinite bounded set has at least one accumulation point, and we got 0 is the accumulation point for this set. So it means this statement of the theorem is true. Let us do some more examples. What about this set S1 mod S1 Z such that mod Z less than 3. So mod Z less than 3 means the circle and boundaries are not there. Union Z equal to 3. Z equal to 3 means only this point, right? So what about this set? Is this set is closed set or open set or whatever it may be? So look at it here. Look at this piecewise, this set. This set is open because no boundary, right? But union with Z equal to 3. Z equal to 3 means the boundary is included, some boundary. So this set is neither open nor closed, right? Because closed means full boundary should be there. But if I show you, if I get any neighborhood, right? So some part is going to be outside of the set. So this 3, Z equal to 3 is the boundary point, right? So all the boundaries are there, then we can say that set is closed. So this set is neither open nor closed, right? Similarly, what about this set? The same structure for the second. Only this second piece is going to be your, real part of Z. This should be real part of Z, right? Real part of Z equal to 3. So real part of Z is going to be 3. So this line, this open disk along with this line, and we have already seen that this point is no longer boundary point. All boundary points are missing, right? If you take any point, you can draw a circle neighborhood of this, then this neighborhood is not contained in this set. So this is not at all interior points, right? And this is, you can say some points are outside. So this is the boundary point for this set, right? So this is neither open nor closed, right? Now let us see the third example. All those z such that z equal to x plus iy, x and y belongs to rational. So this set is neither open nor closed. This is again this set, this neither open nor closed. Similarly, set of complex number, set of real number, both closed and open, right? And similarly, empty set is also both open as well as closed. closed, because C complement is, if C is open, assume, then C complement is empty set, is going to be closed, right? Because A is, any set A is open if and only if its complement is closed, right? Complement closed means C is open, okay, and so on. Similarly, what about this set? Whether this set is connected, which one of the set is connected? Z minus R less than or equal to R union Z, all those such that Z plus R is less than or equal to R. So this set is connected. This set is also connected. This is not connected. Why? Because if you see first set, boundaries are the blue line, right? Both boundaries are included. If we remove one of the boundary, right, from here, then it will become S6 set, right? Blue borders are removed. Still this is connected. But if we remove both the blue boundaries from this set, then this set is no longer connected. Let us talk about domains and reason. A non-empty open connected set is called domain, right? And domain together with some, none, or all its boundary points are called the region. So it means that domain, right? And this is a region. So region is a bigger set actually. So every domain is also a region because domain with none of its boundary point, right? And open connected domains. Okay.